Here's something that makes absolutely no sense. Over the last 2 years, the price of AI dropped like a rock. The cost per token fell by around 280 times. It should be dirt cheap by now. And yet, companies are watching their AI bills triple. Cheaper than ever, but somehow more expensive than ever. Welcome to Tech with Kaushik, where we simplify complex technology and make it easy to understand. This is the AI cost paradox. And in the next 30 minutes, I'll show you exactly why it's happening and hand you a battle-tested playbook to cut your own AI bill by 50 to 90% without losing an ounce of quality. Let's get into it. Let me start with a true story that should terrify anyone shipping AI. In late 2025, 2 AI agents got stuck talking to each other, an infinite loop, each one replying to the other over and over. Nobody noticed. It ran for 11 straight days. And when the team finally caught it, the bill for that single runaway loop was $47,000. One bug. No humans involved. 47 grand. Up in smoke. This is the new reality of AI costs, and it's exactly the kind of disaster we're going to learn to prevent. Look at these 2 lines, because they tell the whole story. The green line is the price per token, and it's crashing downward, a 280 times collapse. Logically, your bill should follow it straight down. But the red line, your total spend, is doing the exact opposite. It's rocketing up 320% higher. 2 lines, same graph, going in completely opposite directions. So the trillion-dollar question is, how do tokens get radically cheaper while bills explode? The answer is going to change how you build. And this isn't a rounding error. It's an industry-wide crisis. Global AI spending is forecast to hit $2.5 trillion in 2026. The median enterprise LLM bill grew 7.2 times year over year, and total spend climbed 320%, even as the per-token price fell. These aren't startups being sloppy. These are serious companies discovering that AI economics behave nothing like they expected. Here's the part that should really grab leadership's attention. Despite all that spending, only 28% of AI use cases actually meet their return on investment expectations. Read that again. Nearly 3 out of 4 AI projects aren't clearly paying for themselves. So the money is pouring out, but the value isn't reliably coming back. That gap between spend and return is not a strategy problem. It's an engineering problem. And engineering problems have engineering fixes. So let me reframe this for you, because it's the single most important idea in this whole video. If your AI bill doubled this quarter, you do not have a pricing problem. The tokens got cheaper, remember? What you have is a usage problem. Your systems are consuming far more tokens than they need to, in ways you probably can't even see yet. And the beautiful thing about a usage problem is this. Usage is something you control. You can engineer it down. So here's my promise for the next half hour. First, I'll show you exactly why these bills explode, the hidden mechanics of token economics that nobody explains. Then I'll give you a 7-layer savings playbook that production teams use to cut costs by 50, 60, even 90%, without degrading quality at all. No fluff, real numbers, and techniques you can apply this week. Deal? Let's start by opening up the engine. Part 1. Why your bill explodes. To fix costs, you first have to understand what you're actually paying for. And I promise, once you see these hidden mechanics, you'll never look at an API invoice the same way again. Let's demystify token economics. First, the pricing detail most people completely miss. You pay for 2 kinds of tokens, input and output, but they are not priced the same. Output tokens cost 3 to 10 times more than input tokens. On a typical model, input might be $3 per million tokens, while output is 15. That's a 5 times multiplier. Why? Because the model generates output 1 token at a time. It's far more expensive than reading your prompt. The takeaway: controlling how much your AI says is often more powerful than controlling how much you send it. Now here's a sneaky one. Modern reasoning models think before they answer, generating internal reasoning tokens that work through the problem. The catch? Those reasoning tokens are billed as output, but they never appear in your response. You pay for a mountain of thinking you never even see. On a complex task, this invisible reasoning tax can quietly dominate your bill. If you don't need deep step-by-step reasoning for a task, don't turn it on. You're paying for every hidden thought. And here's the biggest culprit of them all, agents. A simple chatbot makes one call to answer you. But an AI agent? It plans, it selects tools, it executes, it verifies, it recovers from errors, it generates a response. That single user request can fan out into 10 to 20 separate model calls. In fact, in most enterprise AI budgets, inference from these agentic workflows eats over 85% of the spend. The intelligence isn't expensive. The sheer volume of calls is. Let's put real numbers on it. A simple chatbot query, 1 call, about a penny. A basic RAG pipeline, 2 or 3 calls, for cents. A coding agent fixing a bug, 8 to 15 calls, 27 cents. A multi-step research agent, 12 to 20 calls, over 50 cents per task. Same user, same AI feature on the surface, but a 50 times difference in cost depending on how much autonomy you gave it. Multiply that by your daily volume, and you can see how fast this compounds. It gets worse, because context doesn't scale linearly, it scales quadratically. Thanks to how attention works, a 128,000 token context window can cost roughly 64 times more to process than an 8,000 token one. So every time you stuff just a bit more context into the prompt to be safe, you're not adding a little cost, you're potentially multiplying it. Bigger context windows are a feature you pay for very, very steeply. Here's a cost most people never realize they're paying: the resend tax. In an agent loop, each new step appends the latest result to the conversation and then resends the entire accumulated history on the next call. So a 10-step task transmits that growing context 9 times over. Your 2,000 token starting prompt can balloon into tens of thousands of billed tokens by the end, not because of new information, but because you kept resending the old stuff. And this is the trap that catches almost everyone. A single agent conversation costing 14 cents feels completely trivial in a demo. But scale it up, 3,000 employees, each triggering it 10 times a day, and you're at $4,200 a day. That's $1.5 million a year from one minor interaction. The unit economics that look adorable in a prototype become a business-critical crisis in production. That's the token cost trap. So here's the paradox, finally solved. Cheaper tokens didn't lower bills. They lowered the barrier to using way more of them. Agents, longer context, reasoning modes, more features. Every price drop made new token-hungry patterns economical, and we adopted all of them at once. Cheaper tokens didn't cut spending. They bought more consumption. Now that we know where the money goes, let's go get it back. Part 2. Follow the money. Before you optimize a single thing, you need to know where your tokens are actually being burned. Because if you optimize the wrong layer, you'll spend engineering effort for tiny returns while the real leak keeps draining your budget. Let's do the autopsy. For most production deployments, the bill breaks down roughly like this. 40 to 60% goes to the main task, the actual work you want done. 10 to 20% is retries and tool call loops. 10 to 15% is stable system prompt overhead, the same instructions repeated on every single call. Another 10 to 15% is pathological inputs, the rare tasks that cost a fortune. And 5 to 10% is background work like classification and routing. Know these numbers for your system, and you know exactly where to aim. Let's zoom in on a silent budget killer, system prompt repetition. Most production agents carry a system prompt of 2 to 8,000 tokens, instructions, examples, formatting rules. And here's the thing. Without caching, that entire block is resent and rebuilt on every single API call. You wrote it once, but you pay for it thousands of times. It's like paying rent on the same room over and over every hour. Hold that thought, because it's the first thing we're going to fix. Next, the outliers. In almost every system, there's a small sliver of inputs, call it the pathological 1%, that each cost up to 50 times the median task. Maybe it's an enormous document, a runaway loop, or a weird edge case that sends the agent spinning. These rare monsters can quietly consume a huge chunk of your total bill. The lesson: you can't just optimize the average case. You have to hunt down and cap the extremes. And if you're running multiple agents together, watch out for token flooding. The common anti-pattern is agents passing each other their complete conversation histories, the full transcript of everything they did. But the next agent doesn't need the whole play-by-play. It needs the structured result. Every time you pass a full transcript instead of a tight summary, you're paying to reprocess information that's already been handled. Multi-agent systems get exponentially expensive without this discipline. So the golden rule before we touch a single optimization: diagnose before you optimize. Instrument your system, break down that bill, and find your single biggest line item. Because the fastest path to savings isn't applying every trick. It's applying the right trick to your biggest leak first. Now, let's open the toolbox. This is the part you came for, the 7-layer savings playbook. These are the exact techniques production teams use to cut their bills by 60 to 90% without sacrificing quality. And the magic is that they stack. Each layer targets a different part of the bill, and together they compound into massive savings. Grab a notepad. Let's build your defense. Layer 1, and it's the highest ROI move you can make: prompt caching. Remember that giant system prompt you repay for on every call? Caching stores that repeated prefix so the model can skip reprocessing it. The savings are dramatic. On some providers, cached input tokens cost about 1/10 of normal, roughly 30 cents per million versus $3. That's up to 90% off your repeated context for almost zero engineering effort. If you do only one thing after this video, do this. But caching has a trick to it. To get high cache hit rates, structure your prompts with the static content first, the stuff that never changes, and the dynamic content last. Put the fixed instructions and examples up front so they can be cached, and keep the changing bits at the end. Research on real agentic workloads shows this strategic ordering delivers consistent savings of 41 to 80%, while naive full-context caching can actually backfire. Small change, huge payoff. Layer 2, semantic caching. Regular caching matches identical prompts. But semantic caching goes further. It recognizes when two differently worded questions mean the same thing. How do I cancel my subscription? And where do I end my plan? Can hit the same cached answer. You embed each query, check for a close match, and if you find one, you serve the stored response instantly. No model call at all. For support and Q&A workloads, hit rates of 15 to 40% are common. That's free answers. Layer 3, and this one's a giant: model routing. Here's the core insight. Not every task needs your smartest, most expensive model. So you build a tiny, cheap classifier that looks at each request and routes it to the smallest model capable of handling it. Simple extraction and classification go to a cheap model. Only real reasoning and synthesis go to the flagship. Teams doing this see 50 to 80% cost reductions with no measurable drop in quality. Stop paying Ferrari prices for grocery runs. Let me show you why routing matters so much. The price gap between models is enormous. The same task routed to a frontier reasoning model can cost up to 190 times more than on a fast, small model. 190 times. So if you're blindly sending every trivial request, is this spam, yes or no? To your most powerful model, you are lighting money on fire. A 1-cent classifier call can save you dollars downstream. Layer 4, batching. If a workload isn't time-sensitive, think overnight classification, data enrichment, generating embeddings. Don't process requests one at a time in real time. Send them as a batch. Provider batch APIs typically give you a guaranteed 50% discount in exchange for a slower turnaround. And if you're self-hosting, smart batching with something like VLLM can boost throughput up to 23 times. Same work, half the price, just because you weren't in a hurry. Layer 5, control your output. Remember, output tokens are the expensive ones, 3 to 10 times the price of input. So a shockingly simple win. Tell the model to be brief. A system prompt line like, be concise, respond in 2 to 3 sentences unless asked for detail, can cut output tokens by 40 to 60%, with minimal quality impact for most use cases. You're not making the model dumber. You're just telling it to stop rambling on your dime. Layer 6, context compression. Instead of dragging the entire conversation history along on every call, summarize it. Keep it tight, running summary rather than the full transcript. And wherever you can, demand structured output like JSON instead of verbose free text. Structured responses are shorter, cheaper, and easier for your code to use. Less context in, less context out, lower bill, and often better reliability too. Layer 7, token budgets and guardrails. Remember our $47,000 horror story? This is how you prevent it. Set hard token budgets on every agentic task, a maximum number of steps, a maximum spend, a loop breaker. If a task blows past its budget, it gets cut off and flagged, not left to run for 11 days. Guardrails turn catastrophic, unbounded risk into a small, predictable, capped cost, non-negotiable for production. Now here's the beautiful part. These layers compound. Caching cuts your repeated context. Routing cuts your per-call price. Batching has your background jobs. Output control shrinks the expensive part. Stack them, and each one multiplies the savings of the others. That's how teams get from a scary red bill down to a fraction of it, 60, 70, even 90% lower. No single layer is magic. Together, they're transformative. But do them in the right order. Most engineers instinctively reach for the fancy stuff, quantization, custom infrastructure, first. That's backwards. Start with prompt caching. It's nearly free, fast to implement, and returns the most savings on high reuse workloads with zero accuracy risk. Then routing. Then batching. Save the heavy engineering for last. Get the sequence wrong, and you'll burn weeks chasing small wins while the big savings sit untouched. And here is a bonus lever gaining serious momentum: open source and small models. For narrow, well-defined tasks, classification, extraction, summarization, you often don't need a giant frontier model at all. In 2026, open source models like Llama, Mistral, and Qwen crossed 38% of enterprise token volume for the first time. Point those cheap, capable models at your high-volume grunt work, and reserve the expensive frontier models for the genuinely hard reasoning. So what does all this actually add up to? Take that support agent handling 10,000 tickets a month. Unoptimized, it was costing around $16,000. Apply caching, routing, output control, and budgets, and that same workload, same quality, same experience for the user, drops to around $3,000. That's an 80% cut, not by using a cheaper model everywhere, by engineering the system intelligently. Before we wrap, one final shift, and it's a mental one that separates the teams who control their AI costs from the teams who get controlled by them. Because all the tactics in the world won't stick without the right way of measuring success. Here it is: stop obsessing over cost per token. A cheap token that produces a wrong answer you have to retry isn't cheap at all. The metric that actually aligns engineering with the business is cost per successful output. How much you pay for one correct, useful result. Sometimes a pricier model that nails it on the first try is cheaper than a bargain model that fails 3 times. Optimize for successful outcomes, not raw token price. To manage costs, you first have to see them. This is where TokenOps comes in, FinOps, but for tokens. The foundation is simple. Tag every single LLM call with metadata. Which team, which feature, which environment. Suddenly, your bill goes from a terrifying black box to a clear breakdown you can act on. You can't optimize what you can't attribute. Visibility is where cost control actually begins. And this becomes a continuous loop, a flywheel. Visibility, see where the money goes. Allocation, assign it to teams and features. Optimization, apply the layers we covered. Governance, set budgets and guardrails so it stays optimized. Then back to visibility. Cost control isn't a one-time cleanup you do when the bill scares you. It's an ongoing discipline that keeps your AI profitable as you scale. So here's your homework, and I really want you to do it tonight. Ask 3 honest questions about your AI systems. Do you cache your repeated prompts? Do you route requests by task difficulty? And do you have hard caps to stop a runaway loop? If you just winced at any of those, good. Now you know your first move. Tell me down in the comments. What's your rough monthly AI bill? And which layer are you going to try first? And I've put a free 1-page cost-cutting checklist, every layer from this video, in the description. Go grab it. Let me leave you with the one line that sums it all up. Cheaper tokens will not save you. Better engineering will. The teams that win the AI era won't be the ones with the biggest budgets. They'll be the ones who turn cost into an engineerable variable and squeeze real value out of every token. If this saved you money, or a future panic attack, hit subscribe, because this is exactly the kind of practical AI deep dive I make here on Tech with Kaushik. I'm Kaushik. Stay curious, build smart, and I'll see you in the next one.